Good evening. Uh, Last class we were discussing about LPP, right? We were looking at some problems. Okay. So let us start with one problem. Illustration 11. You guys are preparing at home? Are you studying? Yeah, you keep studying at home also, otherwise you'll forget. Okay. Let's see illustration 11. Okay. A company produces the products PQR from three raw materials A, B, and C. 1 unit of product P requires 2 units of A and 3 units of B. Okay, so let us, there are three products P, Q, and R, right? And there are three raw materials A, B, and C. He says 1 unit of P requires 2 units of A and 3 units of B, 4 units of C. Okay, and for Q it is 2 units of B and 5 units of C. Okay, and for R it is 3 units of uh, 3 units of A, 2 units of B, and 4 units of C. Okay, yeah. The company has 8 units of A, 10 units of B, and 15 units of C. Okay, this is available material, and here you will have the profit, which also he has given you as 3, 5, and 4. Okay. Okay. So based on this, can you give me the functions, the objective function and the constraints? So what will we assume as variables? P, Q, and R, right? So this will be x1, x2, and x3. Yeah. Give me the functions. Objective function. 3x1. Yeah. It is maximize z is equal to, yeah, 3x1 plus 5x2 plus 4x3. Correct. Okay. And then the constraints. Two x1 plus 3x3 less than equal to 8. Correct. Similarly, 3x1 2x2 plus 2x3 to 10. Yeah. And last one. Yeah. And you'll also have x1, x2, x3 greater than equal to 0. This is 5. Let me write this function in the top, okay? Write it here. 4x1 plus 5x2 plus 4x3 less than or equal to 15. Let's see if he has got the same answer. Okay, so have we done anything wrong here? What does the question say? R requires sorry for we have to see for P, right? P requires, okay, so there is no 4 here, so we have made a mistake. He says P requires 2 units of A and 3 units of B, right? Okay, so this is the last equation. Okay, yeah. Okay, so this is the first part, right? Formulate the problem mathematically. And now the second part, write the dual problem. So we have seen the dual problem, right, in the last class. So there were 3 steps. What is first step? Yeah, so this is the primal, correct? So we already have the primal. What is the second step? Correct. So is this in the canonical form? Can you check? So for maximize, all the constraints should be less than, correct? So is this in canonical form? Yes. So this is already in canonical form, okay? Because you have 3 less than, and this is a maximize function, okay? Yeah. And what is the third step? Okay. So let us write the canonical form here. Maximize z is equal to 3x1 plus 5x2 plus 4x3. Huh? No. Yeah. And the constraints are 2x1 plus 3x2 equal to 8. Okay. Hmm? Hmm? Okay. So this is your canonical form. Okay. So as per step 3, what happens? Maximize will become minimum, right? So in the dual form, your maximize will become minimize z, and let us assume variables as y. Okay. So minimize. Okay. Now your objective function, what will happen for the objective function? Constraints will become variables, correct? So it is 8y1 plus 10y2 plus 15y3. Okay. So this is your objective. Let us come to the constraints. Okay. So constraints, what will happen? We have to make a matrix and transpose it. You remember? Yeah. So first let us make a matrix 2, 3, 0, 3, 2, 2, 0, 5, 4. Correct? Let us transpose this. What it will happen? 2, 3, 0, 3, 2, 2, 0, 5, 4. Correct? This is 5. So let us write the same. 2y1 plus 3y2, and for minimize it will be greater than or equal to, right? You remember the table, and this will become, your variables will become your constant 3, right? Next it is 3y1, 2y2, 5, na? 5y3. What did he get? He got 5 only? Yeah. 5y3 greater than or equal to 5. Next 2y2 plus 4y3 equal to 4. Okay? Understood? No doubt, right? Yeah. So if you want, you can copy. I will have to erase this part. Done? Yeah. Okay, so in this problem, we will also see two more concepts. Okay, we already discussed this in theory. So you remember what is slack variable and surplus variable, right? So in less than problem, we will, what we will do? In dual form, right? Yeah. So we will add 1 plus and make this equal to. This is called surplus variable. I have told you, right? Yeah. So in this problem, we are going to use the concept of surplus variable and also the concept of basic feasible solution. Okay. So first we will make this an equality by adding a constant. Okay. 2x1 plus 3x2 plus s1 equal to 8. Okay. 3x1 plus 2x2 plus 2x3 plus s2 equal to 10. 5x2 plus 4x3 plus s3 equal to 15. Okay. Now you have three equations, right? And how many variables you have? You have 6 variables, correct? x1, x2, x3, s1, s2, s3, right? So you have 6 variables. So the number of unknowns is greater than the number of equations, right? We remember we discussed n is greater than m, right? In this case, what we do, we will equate the now variables which is greater to make n equal to m. So you have to make s1 0, s2 is 0, s3 is 0. So you will get a basic solution for getting a basic solution. Correct? We have discussed this last class. Okay? So now what we are going to do? So we are going to just eliminate these three variables so that we can get a basic solution. So you have 2x1 plus 3x2 equal to 8, 3x1, 2x2 plus 2x3 equal to 10, 5x2 plus 4x3 equal to 15. Now you have three unknowns and three equations. So now you will have to solve for x1, x2 and x3. Can you solve? So how can we solve this? You can multiply, let us eliminate x3. Okay, let us multiply this 2 times. Okay, so you have 6x1 plus 4x2 plus 4x3 equal to 20, right? And you have 5x2 plus 4x3 equal to 15. So just subtract. You have 6x1 minus x2 is equal to 5. Correct? So this is equation number 3 and this is equation number 2 into 2. Understood? So minus 5x2 and 4x2, I got minus x2, 6x1 is the same, this got cancelled. Okay? And I have 2x1 plus 3x2 equal to 8. So let me multiply this into 3. Okay? You have 6x1 plus 9x2 equal to 24. Correct? Let me minus this. Minus 10x2 equal to minus 19. Correct? So x2 equal to 19 by 10. Correct? Yeah. So now this you can substitute in equation 1 and you will get x1 and there will be only one unknown, x3. Okay? So x3 also you can directly get, you just substitute this in equation 3, 5x2, you will get x3. Correct? So you copy this, let me write. So step 1, what I have did is 2 into 2 minus 3. Okay? And step 2 is this equation minus this is equation number 1. Okay? You write properly. So again you will get confused. So any doubt? Yeah, correct. Only if it is asked, but here he did not ask, but although I have done it because in other problems he might ask. And this you solve for the primal, okay? Do not do this for the dual. No, finding the solution, you can do it for the primal or dual. You can do it for anything, but it is better if you do it for primal only. If you do it for dual, you'll get different set of answers. That will also be correct, but you'll get the answers for y, not x. Yeah. Okay. Let me do it again. So you are doing. Okay. So first equation, you have 2x1 plus 3x2 equal to 8. Yeah, s is 0, so we will only take x1, 2 and 3, okay? Second equation is 3x1 plus 2x2 plus 2x3 equal to 10. Third equation, 5x2 plus 4x3 equal to 15. Okay? So, first step, what I am doing is, see, my basic idea is I want to eliminate, now I have three equations, right? So, in my first equation, I have x1 and x2, right? So, I don't have x3. In this equation, I have x2 and x3, I don't have x1. So, I want to use this equation, and with these two equations, I want to solve this equation. Okay? You can do anyway. You can either use these two and also again solve with this. Okay? Okay? So, what I am doing is I am eliminating x3 in these two equations because this equation does not have x3. Okay? So, I have multiplied this into 2. Okay? So, what I am doing is 2 equation 2 into 2 minus equation 3. Okay? So, that will come into 6x1 plus 4x2 plus 4x3 equal to 20. Okay? And I have 5x2 0 plus 5x2 plus 4x3 equal to 15. I am subtracting this. Okay? So, these both will cancel off. I have 6x1 minus x2 minus x2 equal to, this is 5, equal to 5. Okay? Now, in this equation, let us call this equation number 4. Okay? In equation number 4 and equation number 1, I have x1, x2, x1, x2. So, I can solve these two equations. Okay? So, here I was thinking of eliminating x1. Okay? So, I have multiplied this equation into 3 times. Okay? So, I have 6x1 minus x2 equal to 5 and 6x1 plus 9x2 equal to 24. Okay? So, that is what I got, right? 6x1 plus 9x2 equal to 24. and then I have solved for x2. Okay, you can do it anyway. If you want, you can do it this way also. So you can keep these two, and so you have x1, x2 here, right? You can solve for these two also. You can eliminate x. So in this case, if I solve for these two, what I have to do is I have to multiply this 3 times and multiply this 2 times. Then I will get 6x1 and 6x2, 6x1. Then x1 will get cancelled. Okay. Then you will have x2 and x3. Here you have x2 and x3. So again, with that solution, you can do this solution. Understood? Yeah. You can keep this if this is better. Yeah. So this is your step 1. Okay. And in step 2, you will do equation number 4 minus 3 into equation number 1. Okay. You don't have class from 4 to 5, right, today? Daily also, I don't think you are having 4 to 5. Sometimes you have. Das sir subject is completed? SS Das sir? No. What subject was sir taking? Okay, okay, okay. If possible, tomorrow I'll take a class from 4 to 6, okay? Got it? Should I complete it otherwise? I'll complete? Okay. I'll erase a little bit. guys. Okay, now I don't require equation number 2, right? Let me erase this part. Okay. Okay. So the second step was equation 4 minus 3 into equation 1. Okay. So this is my equation 4, that is 6x1 minus x2 equal to 5. 3 into equation 1 is 6x1 plus 9x2 equal to 24. Correct? And yeah. So let us subtract. This is gone. So this is plus, right? Or minus, sorry. This is this equation, okay? So you have minus 10x2 equal to minus 19. x2 equal to 19 by 10. Got it? The remaining steps are simple. Just substitute the value and you will get x1 and x3. Done? Let us see illustration number 14. Okay. So whatever the problems we are not able to solve in class now, you do for homework. Okay. This is because this is already a solved type of a same pattern. I am just skipping it. Okay. So illustration 14, he says maximize z equal to 15x plus 45y. Okay. He asks us what is the slope. Okay, for slope of any straight line y equal to mx plus c, right? This is the equation of a straight line. You know that? Okay. And in this equation, m is nothing but it is the slope. Okay. So let us bring this form, this equation in that form. Okay. Let us, so he has given z equal to 15x plus 45y. So you can just take this side. So 45y is equal to z minus 15x. Okay. So instead of saying this, you can say minus 15x plus z. It's the same thing. Now y equal to minus 15 by 45 x plus z by 45. Okay. So Z by 45 will be your C and minus 15 by 45 will be your M. Okay. So slope M equal to minus 15 by 45. That is nothing but minus 1 by 3. Okay. Just a simple problem. This equation you have to know. Okay. Now let us look at illustration number 16. Okay. So in this problem we will see what is a simplex format. Okay. This the question reads, the simplex calculator company makes a profit of 5 on each model of X and 20 on each model of Y. Each calculator requires the following time in minutes on cleaning and testing machines. Okay. So you have two models X and Y and you have cleaning and testing. He has given you a table for that. Okay. Okay. So let us write our objective and constraint functions. He says profit of 5 rupees on X and 20 on Y, right? And profit is maximized. It's always a maximized problem. So you have 5X plus 20Y. Okay. This is simple. And the constraints, you have 2x1, 2x plus 4y less than or equal to 10. Okay. And then you have 6x plus 3y less than or equal to 12. Simple? Yeah. Okay. Now let us see what a simplex tableau is. Yeah. So simplex tableau, it has this format. You have your constants. Okay. And then you have your decision variables. Okay. It's just putting our equation in a tabular format. Okay. You have x, y, and you have your surplus variables s1 and s2. We saw that in the previous problem. Yeah. So here you will have your maximized problem, right? This is 5 and 20, and you do not have s1 and s2 here. Okay. They are 0. Okay. And next you have x, 2, 4, and so sorry. Yeah. So here we will do plus s1, right? And here you will do plus s2. Okay. And the variable for s1 is 1 and for s2 is also 1, correct? So 1 into s1 and 1 into s2, correct? So for first one it is 1, 0. For the second equation it is 6, 3, 0 and 1. Okay, very simple, there is nothing, and here you have your less than. And this is, you have z, and this c which we have taken, we just write that as c minus z. Okay. So your z will be 0 and your c minus z will be 5 minus 0. Okay. 20 minus 0, 0 and 0. Okay. This is just a simplex tableau. This is a format. So sometimes what he does, he can give you the problem in this way, and he can also tell you to write the objective and the constraint equations. Okay. In that case also you should be able to do it. So if the same problem, if he asks you to give the objective function, so you will have maximize Z, 5x1 plus 20y1. Okay. Similarly, you will have this thing. Right. So the next problem is like that only. Illustration 17. Okay. And how will you know whether it is a maximize or a minimize? This can also be minimize Z, right? So this thing he will give you in the question. Okay. Yeah. Yeah. So in problem number 17, if you see, the initial matrix of a maximization linear programming he has given. Okay. So this thing he will give you in the question, and these numbers, based on that, these numbers you have to write the equations. Okay. And always this will be in a canonical form. Okay. So for maximize it will be less than, and for minimize it will be greater than. Okay. Understood? Yeah. Okay. So the next problem we will look at it afterwards. Problem number 17, yeah, 18 actually. We will let us cover the basics in transportation in this class, and the next class we will do problems for understanding. Okay. 4.5 transportation. Okay. So in any transportation problem, okay, what is a transportation problem basically? A transportation problem is nothing but, suppose you have a distribution company, okay? You have warehouses. You have warehouses at locations A, B and C, okay? You have goods in your warehouses, and you have delivery locations. Say you have to deliver to location D1, D2, D3 and D4. Okay. So now the transportation problem is nothing but it will help us to come with a route, or the distribution of your goods. Okay. So you will have goods, right? You will have, say, suppose quantity 100, 200, 300. Okay. Let us suppose say these are your manufacturing plants. Okay. A, B and C are manufacturing plants, and D1, D2, D3, D4 are your warehouses. Okay. Now these also might have some capacity. Okay. You say this has 200 capacity, 100 capacity, 50 capacity and 40 capacity. Okay. And there will be some kind of a cost associated to transport goods from these locations to your destinations. Okay. So say suppose from your factory A to location D1, it will cost you rupees 10 per unit. This will cost you 5 per unit, 2 rupees per unit and 20 rupees per unit. Okay. So your main objective is to transport these 600 units, okay, to these warehouses and at a minimum cost. Okay. So suppose for this the cost is 10, 5, 2 and 20. From B to D1 the cost may be 5. Okay, this may be 10, 16, 15, 40, 30, 20, 10. Okay. This is your cost per unit. This is your cost per unit. And these are your goods and these are your destinations. Now the transportation algorithm, it helps us to arrive at a minimum cost. Okay. So see, suppose this is 100, right? And you have 100 here. You can directly send this to here. You will incur 500. But that is not the least cost, right? You have 2 here. So maybe you can send the 50 here. You will have 100. And then next you can send it here, another 50. So you'll have 250, right? 350 is your cost. Instead of directly sending it to here, if you just split it this way, you have saved 150 rupees, right? So transportation algorithm helps us in getting the minimum cost for transporting goods from your source to your destination. Okay? So there are several algorithms, or you can say several methods, okay, for transportation. Okay? So what are those methods? So basically you have five methods. Okay? The first method is your northwest corner rule. Okay? This is also called your Cooper-Chance method. Cooper-Chance method. Okay? Next method is minimum row method. Next is minimum column method. Next is minimum cost method. Minimum cost matrix method. Okay, and the last is your Vogler approximation method. Okay. Okay. So these are your 5 methods of transportation problems. Okay. So I will explain these methods with the help of a problem. Okay. So he has given you a problem here. Example number 2 in page number 152. Okay. You have 3 factories, O1, O2 and O3. Okay. So this is for our understanding. O will be your origin and D will be your destination. Okay. Yeah. And you have 4 destinations, D1, D2, D3, D4. Okay. And he has given you 3 factories and produces 7, 9 and 18 units. Okay. So O1 you have 7, 9, 18 units, right? And you have capacities of your warehouses D1 to D4. This has 5, 8, 7 and 14. Okay. Now he has also given you the cost per unit from O1, O2, so okay. So he has given you the cost from your sources to the destinations. Okay. So, okay, how do you write this? I will tell you. You will have, this is called your, this is your units. Okay. This is the units and this will be your cost here. Okay. So this will be 19, 30, 50, 10. Let us just note down the costs. Okay, so these are your costs. This is nothing but the units, so which you are going to distribute. So this is the notation. Okay, so this is how we'll solve all the transportation problems. Okay, okay. Now we are going to look at the first method, northwest corner rule method. Okay, in this method, what will we do? We will nothing. We will not look at anything. So here you will just start distributing. You have 7 units. Okay, so you will not look at the least cost or anything. So 7 units. This can take 5 units. Okay, this can take 8. You have 2 balance 2. You are done. Okay, rest will be 0 and 0. Okay, similarly you have 9 units, but this is already full, right? D1 does not have any capacity. You have already filled the capacity of 5 units here. So next you will come here. How much capacity is left? 6. You will come here. How much we can distribute more? 3. You are done. Okay? You are 18. So you tell me, how do we distribute 18? How much will it come here? 0 here, 0 here, 4, right? 7 minus 3. Yeah, you have only 4 slots left. Okay? Here you have 14, you have 14. You are done. Okay? This is northwest rule. Here you pay no attention to the cost. You only look at the capacity, you fill the capacity. And you go from this way. You go first row, second row, and third row. Okay? Now you have to calculate the cost. So cost will be, how will you calculate the cost? So 5 into 19 plus 30 into 2. Okay? So cost will be nothing but 5 into 19 plus 30 into 2 plus 30 into 6 plus 40 into 3 plus 70 into 4 plus 14 into 20. How much is the cost? You can use a calculator. You are allowed calculator in the exams, right? One zero one five. Okay. Okay, let us extend for 5 minutes. I will cover you these 4 methods. Okay, so that again, if you get a break, you will forget. Yeah. So this is your northwest corner rule method. Okay. Now let us. You have copied, right? You have not copied? Okay, you copy. Okay, good. Okay. Yeah. Now let us take a look at the second method. What is your second method? Minimum row method. Okay? Okay. So here, what is your row? This is your row, right? Okay. Now in your row, you have to see which has the minimum cost. Which has your minimum cost? 10. And this has 14 capacity, correct? So you can give 7 directly here. Yes? Okay. Now go to the second row. Now which has the minimum cost here? 30. So you cannot completely give 9 because it has a capacity of 8. So you will have to give 8. And next, you will have to go with the next minimum, 40. Will be 1. Okay? Third one. Minimum is 8. And you have a capacity of 0. You cannot give anything here. Next, 20 you have a capacity of 7. So how much more we have to distribute? 11 more. Correct? So next minimum is, how much can we distribute? 5 only. You have only 5 capacity here? Yeah? So how many you are done? You are done with 12. You have 6 more and you have only 1 slot available. You have to distribute 6 here. Okay? Understood? Simple? Cost, yes. Cost and capacity also, so you have to always have the capacity in mind, because if it is 5, you cannot give more than 5, right? Like that. Okay? So this is all 0. Right? So you can calculate the cost here also, similarly. So it will be 10 into 7 plus 8 into 30 and that way. Okay? This is minimum row method. Now, so now you might have already understood, you can guess what is minimum column method, right? First one was northwest corner. This is row. This is row. Okay, next one is minimum column method. Now this is column, right? Okay. Now out of these 3, which is minimum? 19, right? So we can give all the 5 here. Okay, correct. So 5 is done, so nothing else here. We have nothing left. Here it is 8. Which is the lowest? You can give the 8 here because you have a capacity of 18 already. Correct? Now here 7. Which is minimum? 40. It is 9. You can take 7 here. No problem. Completely distributable. 14. 10 is minimum. You have only 2 left because 5 is occupied. Now 12 more you have to distribute. What is next? 20, but only 10 left. Correct? Remaining, you have 12, only 2. You have 2, you can do 9. Okay? Okay? We will stop here, otherwise you will get overloaded. We will take a look at this again in the next class also, okay? Before we go to the next 2 methods. Okay? You can note down in the next class also. Okay?